You're watching a video in bed. The router is in another room. There's a concrete wall between you. You have full signal.
Light can't pass through that wall. Sound barely can. But Wi-Fi goes through concrete, wood, and steel, like they're not even there. How is that possible?
The answer involves a form of invisible light, equations written 150 years ago, and the same physics that heats your soup.
It's not magic. It's not air. It's not a special internet substance. Wi-Fi is light, electromagnetic radiation, just like visible light, just at a frequency your eyes can't detect.
In 1887, German physicist Heinrich Hertz proved that electromagnetic waves could travel through the air. He generated a spark on one side of a room and detected it wirelessly on the other side.
But the real genius behind Wi-Fi was James Maxwell. In 1865, before Hertz, before radio, before any of it, Maxwell wrote 4 equations that perfectly described how electromagnetic waves work. We still use them today.
From Maxwell's equations to Hertz's spark, to the first wireless network in 1971, to the Wi-Fi standard in 1997, it took 130 years to get from the math to the router in your living room.
So Wi-Fi is light. But how does light carry a Netflix movie? How does it get through walls? And how does your phone know what to do with it?
The router gets data from the internet as electrical signals through a cable. Inside, a chip converts that electrical data into radio waves, specifically microwave frequency radio waves, and broadcasts them through an antenna.
But how do you put data into a wave? Your movie is just ones and zeros. The router encodes them by modulating the wave, changing its pattern thousands of times per second to represent the data.
The wave travels at the speed of light, 300,000 kilometers per second. From your router to your phone, maybe 10 meters away, it takes 0.0000003 seconds, less than a blink. Modern routers broadcast on 2 frequencies. 2.4 GHz has longer waves. It travels further and passes through walls more easily. 5 GHz has shorter waves. It's faster but gets blocked more easily.
Your phone's Wi-Fi chip catches the waves, decodes the modulation back into ones and zeros, and your video plays. But we still haven't answered the real question. The wall is solid, concrete. How does an invisible wave pass through solid matter?
Here's the key insight. Matter, including concrete, is mostly empty space. An atom is almost entirely empty. If the nucleus were a football, the electrons would orbit 10 kilometers away. So why can't we walk through walls? Because the electron clouds of atoms repel each other electromagnetically. When your hand touches a wall, you're not touching atoms. You're feeling 2 electron clouds pushing back against each other.
But Wi-Fi waves have a much lower frequency than visible light. Concrete's molecular bonds absorb visible light. That's why walls are opaque. But Wi-Fi's frequency is too low to interact with those bonds. It slips through.
But some materials do block Wi-Fi. Metal reflects it. Free electrons absorb the wave. And water absorbs 2.4 GHz specifically, the same frequency as your microwave. Your body is 60% water. You are literally blocking Wi-Fi.
That's why you get dead spots in certain rooms. Behind the fridge, metal. Near the bathroom, water pipes. Behind thick concrete pillars, too much matter to slip through.
And it works both ways. Your phone isn't just receiving, it's also transmitting back to the router. That's how the router knows what you're asking for.
Now, here's something wild. Your router is broadcasting to every device in your home simultaneously. One stream of waves, but your phone gets your movie, not your neighbor's. How?
Every Wi-Fi device has a unique hardware address called a MAC address. The router uses this like a postal system. Each data packet is labeled with a destination address. Your phone only processes packets addressed to it.
Here's the secret. The router isn't actually talking to all devices at the same time. It switches between them thousands of times per second, so fast that it feels like simultaneous. It's taking turns at the speed of light.
But the total bandwidth is fixed.
More devices connected means each gets a smaller share. That's why streaming in HD drops to SD when everyone's home and on their devices. Wi-Fi 6 and 7 use a technology called MU-MIMO, multiple simultaneous streams to multiple devices at once. It's genuinely faster and more efficient.
Here's something uncomfortable. Your Wi-Fi waves don't stop at your walls, they keep going. Your neighbor's devices can detect your router's signal. So how is your data private?
Encryption. Your router scrambles all data before broadcasting it using a mathematical key. Even if your neighbor captures the waves, they see meaningless scrambled data. Only your router and your device have the key to unscramble it. Public Wi-Fi in coffee shops is usually unencrypted or uses shared encryption everyone knows. Anyone nearby with basic software can capture and read your data.
A VPN adds an extra encryption tunnel on top, even on public Wi-Fi.
Wi-Fi doesn't actually stand for wireless fidelity. That was a backronym invented later to explain the name. Wi-Fi was created by a branding agency hired to make IEEE 802.11 sound cool. The Wi-Fi symbol, those fan lines, represents radio waves emanating from a source. Designed in 1999, now one of the most recognized symbols on the planet.
Astronauts on the International Space Station have Wi-Fi. They use it to video call Earth, browse the internet, and send emails from 400 kilometers up.
But the signal bounces through geostationary satellites 36,000 kilometers up. Round-trip latency? 2.4 seconds. Their video calls have a noticeable delay. The foundational technology behind Wi-Fi was co-invented by Hedy Lamarr, one of Hollywood's biggest stars in the 1940s. During World War II, she developed a frequency-hopping spread spectrum to prevent radio signal jamming. So here's the full chain. Maxwell's 1865 equations described the wave. Hertz proved it existed. Engineers learned to modulate data into it. The wave passes through your wall because its frequency is too low to interact with matter. Your phone decodes it, Netflix plays. Right now, Wi-Fi waves are passing through your body, through the walls around you, through everything in the room. 150-year-old math made visible as the video you're watching. Kinda changes how you look at empty air, doesn't it? Next episode, sleep. Why do we spend a third of our lives unconscious? What's your brain actually doing? Subscribe.